This video is about similarity. Similar figures have the same shape but are of different size. So you'll often hear the word enlargement, that's referring to similar figures. In similar figures, corresponding angles are equal. As you can see here, all of the angles in these triangles are equal, indicated by the same number of lines. And the corresponding sides are not equal as they are in congruent figures, but they are within the same proportion or ratio. And we call this proportion or ratio the scale factor, which is the image length divided by the original length. And we'll do an example of this shortly. Let's have a look at this image down here. So the corresponding angles are all equal, as I mentioned before. The corresponding sides we write like this. So A over A1 is equal to B over B1, which is equal to C over C1. This shows that they have the same scale factor, and so they're in the same proportion or ratio. How do we write a concluding statement for similar triangles? It will be written like this. So we would say triangle A, B, C is similar to, so 3 vertical lines, triangle A1, B1, C1. You may, instead of seeing these 3 vertical lines, you may see something that looks like this. This also means similar to, so both of these symbols are okay. Let's have a look at an example. So similar to congruent figures, it doesn't have to be triangles. We'll be looking primarily at triangles, but this is an example of 2 quadrilaterals. The question says the following shapes are similar. Write a similarity statement. So let's start off with this first question. So A, B, C, D. This first shape is similar to 3 vertical lines, F, G, H. Oh, sorry, E, F, G, H. E, F, G, H. Right, and that's it for that first one. B, find the scale factor. So we need to find some sides that we have information for both figures. So I'm going to use these 2 sides here. So F and E is the corresponding side to A and B. So it'll be written like this. E, F, so this side here, over A, B, this side here, is equal to 5 over 2. So we can leave that as a fraction, or we can write 2.5. So either of these is correct for the scale factor. So now that we have the scale factor, we can use this to find unknown values. So just scroll up a little bit. X is corresponding to this side here, 3. So we can use our scale factor to find what x is. So since this is the bigger one, we want to multiply 3 by the scale factor to get a bigger value for x. So x will be equal to 3 times our scale factor, 2.5, and that's going to be equal to 7.5. Just going to continue over here for D. So find the value for y. In this case, we're looking at the smaller figure, so we're going to divide by our scale factor, and this side is corresponding to this side here. So I'm going to do 7 divided by our scale factor 2.5 to find the value of y. So y is equal to 2.8. All right, that's all for this question. Let's have a look at proving similar triangles. So just like in congruent triangles, we don't have to prove that all sides are in the same ratio and every angle is equal. We just need to use one of these four strategies. So the first one, side, 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 is that all pairs of corresponding sides are in the same ratio or proportion, as you can see in this example here. So 1 over 2 is the same as 2 over 4, is the same as 3 over 6. Side, angle, side is where two pairs of sides are in the same ratio, as you can see here with 1, 2, and 2 and 4, and the included angle is equal, as indicated by this dot. Angle, angle states that two corresponding pairs of angles are equal. You only need to find two because the angle sum of a triangle is 180 degrees, so if two of them are equal, the third one has to be equal. So that's all you need to find for this one. And then finally, the right hypotenuse side. So the hypotenuses of two right-angled triangles and another pair of corresponding angles are in the same ratio. So the hypotenuse 5 over 10, and then we have 3 over 6, and obviously there is an angle there, which is the right angle. So let's have a go at some examples. We want to set out our working similar to congruent triangles. So in triangles A, B, A, B, C, and Z, X, Y, we need to find a few things. So first of all, I can see very obviously that we've got two equal angles. So angle CAB is equal to angle XZY, and our reason that's given to us. Okay. Next, we have some information about the sides. So I can see here that side AC over its corresponding side ZY will be equal to 3 over 18, which is 6. Let's have a look to see if the other side the other ratio matches. So we'll go AB over XY is 9 over 54, which is also 6. So we can say here that the ratio of corresponding sides are equal. So that means I'll just change color here to show that we've got an angle, and because these are in the same ratio, we have two sides. So our concluding statement, we have triangle ABC is similar to triangle ZXY because of side, angle, side, and that is finished. Let's have a look at another example. Just change my color back. So in triangles X, Y, W, and Z, Y, X, V. First statement, these two angles are clearly the same. So angle XWY is equal to angle Z, V, Y, and that is given. So 2, we have some vertically opposite angles here. So angle X, Y, W is equal to angle V, Y, Z. That's because they are vertically opposite. It's also sort of given with this sort of the same line to represent the same angles. So that means, changing color here, this one is an angle, this one is an angle, that that implies that this angle is going to be the same. So we can make a concluding statement here. Triangle X, Y, W is similar to triangle Z, Y, V because of angle.